Welcome back. Here is another example on logistic goods model. The growth rate of the population of buyer's dog is given. dP over dt is equal to 0.05 p into 1 minus p all over 3,400. The initial population of the dog is 1,200, where time t is measured in weeks. Find the populations of buyer dog after 8 weeks. Here is another problem. How can we solve it? How can we generate the formula for logistic goods model? So, since we are going given dP over dt 0.05, it can be like in the form of this: kp 1 minus p over a. This is our first, that's the first got when we are differentiating, when we are finding the formula of what? Formula for derivative. That is, when we talk about the rate of population is directly to the what? To the population of the resources limitation. In this case, our dP over dt is equivalent to this, our k as our growth rate is equivalent to this, then our p as population is this, then our m is our carrying capacity is this. When we solve this population, when we get our population, this one was equivalent to p is equal to 1 plus m 1 plus a exponential minus kt. When we solve the logistic differential equation of this, we got this. So this simply means our m is our 3,400, our carrying capacity. So our m is what? 3,400. 1 plus our a, we are not giving, a exponential, minus our k is what? Our k is growth rate, which is what? K 0.05, 0.05, then our t. The initial population of the dog is given, so we have been given initial population 1,200. So it means our p of t is 1,200, 1,200. So we have to find the population of buyer's dog after 8 weeks. So how are we going to solve this? So since we have been given this, we have to find what A is before we can what? Find the what? The population of buyer's dog after 8 weeks. So we have to find A, so we can cross multiply. If we cross multiply this, we multiply this, we are going to get, this is 3,400. We are going to get 1,000 multiplied by 1,200 multiplied by 1, we are going to get 1,200 plus 1,200 multiplied by this, we are going to get 1,200 a exponential minus 0.05 t. Remember, at our initial population, our t will be equal to 0. Initial population, that is our start, is 1,200. So our starting time, that is our initial time, will be 0. So in this case, we are going to have 0. So t is equal to 0. So if this one multiplied by this, we are going to get 0. So now I have 3,400 is equal to 1,200 plus 1,200 a raised to power 0. So anything raised to power 0 we get 1. So in this case, we are going to have 3,400 is equal to 1,200 plus this 1,200 plus. So this one we can equivalent this one to, we can take this one, we can take 1,200 to here, so that this one will remain as where it is. 1,200 is equal to 1,200. Anything raised to power 0 is 1. Multiplied by a, we have 1,200 a. 3,400 minus 1,200. What are we going to get? 3,400 minus 1,000, 2,200. 2,200 is equal to 1,200 a. So if you divide both sides by 1,200, we are going to get a as well, 2,200 over what? 1,200. So if you divide it by 1,200, we are going to get 1.8333. So our a is 1.83. So from now we can now generate that our 1,200 is equal to 3,400 all over a1 plus 18.3 exponential minus 0.05 t. So in this case we have gotten this. So find the population of biased dog after 8 weeks. Since we have gotten our A like this, so our P of t, we have to change our one of we have to find P of t after 1 week. So we are not going to use 1200. We have to use what? P of t, because we don't know what the population it is. So 8 weeks, 8 weeks, that's our what? Our time. Our time is what? 8 weeks. T is equal to 8 weeks. So our P of t we are not given. So we have to calculate the population of that time. So when our P of t is equal to M, our M is what? Our M is what? 3400 all over 1 plus A. Our A is what? 1.83. Our growth rate is what? 0.05. Then our T is what? Time 8. If you multiply 0.05 multiplied by 8, what are we going to get? So our P of t are going to get 0.4. 3400 all over 1 plus 1.8 to the exponential minus 0.4. So what is the exponential raised to 0.4? So our exponential raised to minus 0.4 is 0.673. 6703. So our P of t is equal to 3400 all over 1 plus 1.83, 0.6703. If you multiply this by this, what are we going to get? If you multiply, we are going to get. So our P of t multiplied by 1 point. So our P of t multiplied by 1.83, we are going to get 1.226. So our 3400 all over 1 plus. So when I multiply 1.83 multiplied by this, I got 1.227. 1.227. So 1.227, we are going to get what? 3400 all over 2.227. So if you divide 3.00 divided by 2.227, we got our P of t is 1526.7. So this can be equivalent to what? P of t as is approximately to 1527. So population of biased dogs after 8 weeks is what? 1500. Population after 8 weeks of biased dogs is what? 1527. So this is how to solve the growth rate of the populations of biased dogs.